In the vast expanse of the cosmos, where mysteries abound and the stars hold secrets older than time itself, one celestial beacon has captivated humanity for centuries, a guiding light in the night sky, Polaris, our North Star. But what if we told you that something strange is happening to this iconic star? Welcome to another cosmic journey where we'll uncover the mystery of Polaris, the North Star, and the new revelations that are baffling astronomers. So buckle up, stargazers, as we explore why Polaris, once a symbol of reliability, is becoming one of the most perplexing stars in the universe. Polaris, also known as Alpha Ursae Minoris, or simply Alpha Mi, is a moderately bright star with a slightly yellowish hue. It's the 48th brightest star in our night sky, and is almost perfectly aligned with the Earth's axis of rotation. This alignment makes Polaris appear motionless, standing steadfast as the other stars seemingly revolve around it. Its unique position has made it an essential navigation tool for explorers and travelers throughout history. However, Polaris's role as the North Star is not permanent. Due to the Earth's slow wobble, called axial precession, the position of the North Star changes over time. Around 3000 BCE, a faint star called Thuban in the Draco constellation held the title of North Star. In about 13,000 years, Vega in the Lyra constellation will take its place. Interestingly, Polaris will reach its closest alignment with the North Pole around the year 2102 before it begins to drift away again. For those wanting to locate Polaris today, it's simple if you know where to look. Find the Big Dipper, a constellation shaped like a ladle. The two stars at the end of the Big Dipper's bowl, Merak and Dubhe, are called the pointer stars. Draw an imaginary line extending about 5 times the distance between these stars, and you'll find Polaris twinkling in the sky. Alternatively, you can find Polaris at the end of the Little Dipper's handle. However, the Little Dipper is often harder to spot due to its faint stars. Now here's a fascinating fact. Polaris is not a single star. It's part of a multiple star system consisting of 3 stars, Polaris A, Polaris B, and Polaris AB. Polaris A is a supergiant, 4.5 times the mass of our Sun, with a diameter of nearly 28 million miles. Polaris B is a smaller companion that orbits Polaris A at a distance of about 2,400 astronomical units. Polaris AB, another companion, orbits even farther away at 18,000 astronomical units. With a good telescope, you can observe these companion stars and marvel at the complexity of this star system. Polaris A is classified as a Cepheid variable star. These stars pulsate, varying in size, brightness, and temperature. Cepheid variables are crucial tools for measuring distances across the universe because their pulsation rate is directly related to their brightness. Polaris's pulsations were first observed in 1911 with a consistent pulse period of 4 days. However, something unusual has been happening in recent years. For over 150 years, Polaris's pulsation period had been increasing by about 4 to 5 seconds each year. But since 2010, this trend has reversed, and astronomers are unsure why. One theory suggests that the gravitational interaction with its companion star, Polaris B, could be causing these fluctuations. Another possibility is that Polaris may have been 2 stars that collided millions of years ago, rejuvenating the star and making it behave unpredictably. In 2022, researchers at Queen's University in Canada made a groundbreaking discovery. Polaris has a magnetic field. This was the first time a magnetic field was detected in a Cepheid variable star. Magnetic fields can have profound effects on a star, influencing its stellar winds, internal structure, and rotation. This discovery could explain some of Polaris's strange behavior, but much remains unknown about how magnetic fields affect Cepheid stars. Despite its proximity to Earth, just 445 light-years away, Polaris has proven surprisingly difficult to study. Using stellar evolution models, researchers estimate Polaris's mass to be about 7 times that of the Sun. However, measurements based on its binary orbit and Hubble Space Telescope data suggest a much lower mass of 3.45 times the Sun's mass. This discrepancy has left scientists puzzled. Could one of the measurements be wrong? Or is Polaris defying the models we use to understand stars? One intriguing explanation is that Polaris may have been formed from a binary collision, 2 stars merging into one. Such events are rare but not impossible and could account for the inconsistencies in its mass, age, and behavior. However, binary collisions don't fit neatly into our current models of stellar evolution, adding another layer of mystery to Polaris. Polaris is surrounded by a beautiful integrated flux nebula composed of dust, hydrogen, and carbon monoxide. These nebulae are illuminated not by a single star, but by the collective energy of all the stars in the Milky Way. Through images captured by NASA's Chandra X-ray Observatory, we can see Polaris and its surroundings in breathtaking detail, offering glimpses into the vastness and complexity of the universe. Polaris, our guiding star, remains an enigma. Its unusual pulsations, magnetic field, and mysterious past challenge our understanding of the cosmos. As researchers continue to study this iconic star, they hope to uncover answers that could reshape our knowledge of stellar evolution and the universe itself. So, the next time you look up at the North Star, remember that it's not just a guiding light, but a cosmic puzzle waiting to be solved. Thank you for joining us on this journey through the mysteries of Polaris. If you enjoyed this video, please give it a thumbs up and subscribe for more fascinating insights into the universe. Until next time, keep your eyes to the stars.